Good morning, students. Students, this lesson is of class 10th for the subject of physics, topic characteristics of sound, which is covered in chapter 7, sound. And this particular topic is on page number 166 of your physics textbook, Concise Physics by Selena Publications, and is being submitted to you on 19th October 2020. All students may now open page number 166 in front of you. If all students are ready, then let us start with our topic of today, that is characteristics of sound. Students, observe the difference between sounds of your family members and also observe the difference in your sound when you whisper slowly or speak loudly. Students, we can distinguish two sounds from one another on the basis of three different characteristics, namely loudness, pitch, and quality of the sound. Loudness, pitch, and quality of the sound. Now, students, today we will learn all these three characteristics in detail. Now, our first characteristic is loudness. Now, students, listen to me carefully. First, I will speak loudness in two different manner. Listen it. Loudness. Loudness. Can you sense some difference? When I said loudness and then I said loudness, you hear two different level of loudness of sound. Students, sometimes when you are not able to hear television clearly, what do? Yes, you increase the volume of the sound. While hearing my audio right now, if you decrease the volume or if you increase the volume, what will happen? You can get a faint sound as well as a loud sound. So students, loudness is defined as the characteristic by virtue of which a loud sound can be distinguished from a faint sound, both having the same pitch and quality. Now, what is loudness? Loudness is the characteristics by virtue of which a loud sound can be distinguished from a faint one, both having the same pitch and same quality. Students, pitch and quality we will learn today only, but a little later. Now, students, further, loudness of sound depends on the amplitude of the wave. Underline this word, amplitude. So loudness depends on amplitude of the wave. More is the amplitude of the sound wave, louder is the sound heard. Underline this also. This is very important. More is the amplitude of the sound wave, louder is the sound heard. Now, students, I hope you all remember what is amplitude. Amplitude is the maximum displacement of the vibrating particle from its mean position. So what is amplitude? Amplitude is the maximum displacement of the vibrating particle from its mean position. Very good. And it can also be defined as distance between mean and extreme position. So loudness is depending on amplitude, and amplitude is the distance between mean and extreme position. Now students, see the diagram given in front of you. I have drawn a graph between displacement and time, where time is drawn along horizontal x-axis and is measured in seconds, while displacement is drawn along vertical y-axis and is measured in meters. Now students, this is a wave. The wave shown in black color, it is a wave. And this blue line is the mean position. This blue line is the mean position of the wave. So what is the amplitude here? The maximum distance between mean and extreme position. So this is amplitude. And in this case, the amplitude of wave is how much? 2 meters. See, maximum distance is 2 meters. Students, don't write amplitude as 4 meter. No, this is incorrect. Okay. What we are having here? We are having amplitude as only 2 meter. So if I talk about amplitude, the value of amplitude here is 2 meter. Now students, coming further, the SI unit of loudness. So SI unit of loudness is phon. P-H-O-N, phon. Now students, I want you to see figure number 1 given on page number 2 of the notes sent to you on 19th October 2020. See the figure here? Now, if you see figure 1, you can see two different waves. Students, I have drawn two different waves. One is shown in blue color. See, wave number B. I have given the name as wave B. Okay, this is your wave B. Fine. And there is one more wave shown, wave number A. This was your wave A. Now, out of wave B and wave A, see, out of this red and blue waves, which is having more amplitude? See, which is having more amplitude? A. A wave is having more amplitude as compared to wave B. What does it mean? It means that A is having more loudness. So we can say that amplitude of wave A is more than amplitude of wave B. Thus, sound depicted with wave A will be heard more louder as compared to wave represented by wave B. So students, today we will learn about more factors which are affecting the loudness of sound. Now, first factor is loudness is proportional to the square of the amplitude. So loudness is proportional to the square of amplitude. When a body vibrates with a greater amplitude, it sends forth a greater amount of energy, and hence the energy received by the eardrum is large. So the sound appears louder. So according to our first factor, loudness is directly proportional to square of the amplitude. Students, do not write that loudness is directly proportional to amplitude. It is a wrong statement. It is not directly proportional to amplitude. Rather, it is directly proportional to square of the amplitude. So the word square plays a very important role. Now, second factor is loudness varies inversely as the square of distance from the source. Now, it means that closer is the source producing the sound, louder is the sound heard by the observer or listener. Now, students, go back to last year and remember when you used to do assembly in school. When there was any announcement, sometimes the students standing ahead in the row used to hear comfortably, while the students standing behind used to hear a very faint sound. Now, why so? Students, at that time, the source was the speaker who was reading the news of the day or the thought of the day. So that person was the source, and you all were listeners. So if the distance between source and listener is more, a faint sound is heard. While if the distance between source and listener is less, then the listener will hear a loud sound. Coming to the third factor, loudness depends on the surface area of the vibrating body. Now, larger is the surface area of the vibrating body, louder is the sound heard. Now, students, see the figure shown in front of you. I hope you all have seen this in your music room. So what is this? This is a pair of tabla. Now students, see the size, the diameter of the two tabla. If you see the diameter of this first tabla, it is more as compared to the diameter of the second one. So if you find the area, then area of bigger tabla, area of bigger will be more than area of this smaller tabla. Fine. What does it mean? It means that the sound produced by the bigger one will be more loud. Okay, so this bigger one will be producing louder sound. Why so? Because it is having more area, and since we are studying today that loudness depends on area of the object where vibration is produced. So now what will happen if you are having more surface area? Students, right now we have discussed about the tabla. So see here, larger is the surface area of the vibrating body. Larger is the surface area of the vibrating body. Louder is the sound heard. Students, based on this fact only, the bell in temples is made big in size. You might have seen that in temples you are having bigger bells. Why? Because the bigger bell will have more surface area and hence will produce a loud sound. Now, in case of stringed instruments like guitar, piano, sitar, a sound chamber is provided to increase the volume of air to vibrate, and hence the loudness increases. Fourth point for today is loudness depends on density of the medium. Students, this we have done in class 9th also. We have studied that a loud sound can be heard in solids as compared to in liquids and gases. So we can say that more is the density of the sound, more is the density of the medium where sound is produced, more louder sound will be heard. So we have more is the density of medium, more is the louder sound produced. So a sound is thus heard louder in solids as compared to that in liquids or gases. Now coming to fifth point, students, this fifth point we have discussed in the last exercise where we studied about resonance. Remember what was resonance? Resonance was the matching of frequency of natural vibrations with external periodic vibrations such that a high amplitude wave is formed. Now today we have studied class that loudness is proportional to square of amplitude. So what does it mean? It means that in resonance we will be able to hear a loud sound. So let us discuss point number 5th given on page number 3. So loudness depends on presence of resonant bodies. The presence of resonant bodies near the vibrating body increases the loudness of sound. Now students, let us do 2 questions based on loudness of sound wave. Question number 1 will be done by me, and second question you will try yourself in your physics notebook. So first question is the ratio of amplitudes of 2 waves is 3:4. Find the ratio of their loudness.